All right. Hi, welcome back. It's near the end of November, getting into the final month of the year. I'm your host for tonight, Agent Ultra. And on the stream, I program stuff in Haskell just for fun, for education, for learning, for whatever. Just to show, that you can write practical software in this kind of weird functional programming language that often gets derided for being completely academic and impractical. And yeah, so we build all kinds of stuff. The last little while, we've been working on wave function collapse. We have somewhat working code for that, but we're building a visualizer on top of it, fixing a few bugs as we go. And yeah, I'm hoping to wrap that up today if we can. We'll see how far we get. And if we do finish up a little early, we've got the possibility of maybe getting into Advent of Code next month. Or maybe we'll take a little vacation on the stream. I don't know. We'll see. It all really depends on what I want to do and what you, the viewers, want to see a little bit to a degree. Without further ado, let's get started though. Let's bring up the code. So if you you're watching for the first time, you're just tuning in, whatever. Wave function collapse is an algorithm for generating like procedural textures. Amongst other things, people have also used it to kind of like generate poetry or 3D models, all kinds of stuff. The gist of it, though, is that you give it some input rule set, and then it uses those rules to generate a bigger output based on those rules. So in our case, our input is just a single tiny image, and then our output is a bigger image that is constructed from overlapping smaller tiles that we cut out from the main image. So the output image will look something similar like the input image in structure and form, but is somewhat randomly generated from it. Right. Okay. Hopefully that will make a whole lot more sense when we actually get the visualizer working, and you can kind of see the output, and I can see the output, which will be the holy grail of this journey that we've been on. Okay. So one of the things that we have to fix this week that we discovered last week was that the texture from list function here, as I mentioned, the to-do, is not quite right. So the indices used in the input source texture aren't lining up with the indices that are created by this list array function here. So I think what we have to do, we kind of already sorted that out, is that we have to zip our own indices from the pixel data there. And then we can construct the array from that and put that into the texture. Okay. So let's get that first. Okay, so the list of A is essentially our texture data that we've pulled out. Yeah, our pixel data, I should say. We're going to put it into our texture. I'm going to be saying that word a lot this evening, texture, as I did last week. Apologies in advance. The naming. It's one of the hardest things in computer science, you know. Okie dokie. So, let's see. The orientation of the indices that we do need for this need to be row oriented. That is, we have to get the X column to increase first before the Y column. So we have a tuples X and Y for the indices of the array. The list array version of this created a list like this, where it was like 0, 1, 0, 2, 0, 3, and so on. And then it would increase x1. It would be like 0, 0, sorry. But you know what I mean. And then we get 1, 0, and so forth. All right. That was the old. The bad. Good, the one we want. It could be 0, 0. That's fine. Then we want it to increase to 1, 0, 2, 0, so on and so forth. And then we want 0, 1, 1, 1, and so forth. Okay. Okay. Let's put a little hole there. Let's play around in the REPL a little bit with zipping. All right, if we just did two lists like this, let's just take 3 elements of that. We just get the diagonal. Which is not quite what we want. Let's see. What else do we want? More like... Let's see if we can do it with a list comprehension. Ultimately like this. Now, if we did it with the list comprehension just like we did with the zip, and y like this, I think we won't quite get what we want here either. Take 3 from that. We get the y increasing first. So we just have to flip that around. Perfect. All right, and that'll just keep going. And then the next part, we need to break that up. So it's like a cycle. We want this to be not necessarily a list from 0 to whatever. We just want to cycle. Cycle takes a list of A and goes to a list of A. So if you do cycle 0 up whatever, we'll take 5 of these, 4 of these. But if we do, that's infinite list. So if we do, sorry, 0 to 2, we take 4 of those. We get 0, 1, 2, 0, 1, 2, 0. It'll do like that forever. So do like 5, 0, 1. Take 10 of those. And then 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, so on and so forth. We'll just keep repeating the cycle. Which is kind of what we want. We want to repeat the rows up to our size. So I think our equation will be something like this, where we have cycle 0 up to, say our size is 9 minus 1, and size will be here the same, say 9 minus 1. And then we have our indices 0, 0, increasing in x first, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, and then 0, 1. There we go. And if we just take a few more, we can see, yeah, okay, that's kind of what we want. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, and so forth. That'll give us a row ordering for the indices there. That's the first part. This part here. And then we have to pair those indices with the values. So that's the first thing we need to do. Pass that to a function. Okay, type inference is kind of breaking down on us a little bit because it doesn't know what we really, really want. And since we're just doing $x's here and we just have x's here, we can just knock that off, go fully point free here. Okay. Yeah, so now we got this hole here wants to be, we get a list of our tuples with our integer a. That's our array constructor, can take that. I believe we have that in data.array. It gets the bounds, then that's what we'll pass in. That's about the shape we want, and then we get an array back, which will wrap up in our texture constructor. So the bounds will be 0, 0, up to size. We can replace this with size -1. And that was size as well. And then we just need, no, we're not quite done yet, so we need to end up with a texture. Okay, and our texture constructor, I believe, is just such a function that we can put in that hole. And I think that covers that. Okay, so let's get our builder going. Stack build, fast, file watch. Actually, let's just use the test runner. Test failure. Oh no, what did I do? Couldn't find something to collapse to. Uh-oh. I don't know why that would be. I don't think we were changing anything about the algorithm. Uh-oh. Maybe we did. Maybe I did. Crap. Okay. No matter. We'll figure it out. Okay. Hopefully I left myself a to-do about it. That part, I think, is okay. Let's see if this works. Maybe not. Yeah. And we got off by 1 error here. Or somewhere. Okay. We might have to fix that before we can actually see if this works. So hopefully that's good. I'll leave it as a little to-do, create a little community commit, and then we'll go try and see what's going on with this failing test. Oh no, I'm running into my silly issue again. But I know how to fix it. We'll just have to exit our Dmax and start that. I should script this. Or fix my VM. Find what the heck's going on there. Try that again. There we go. Alright, we'll modify texture from the list. I try to use row-oriented indices for constructing from PNG. Okay, let's go fix this test now. To-do, algorithm, function collapse. Let's see if I left myself some to-dos. What's the pattern results? Doesn't look like it. Okay, I couldn't find a pattern to collapse to. Was this... Let me just double check my logs here. Okay, so last week we did this fix off by once and removed debug code. I'm pretty sure we had it working at that commit. Or at least before this commit, maybe. Maybe we introduced the bug here. Right. Okay, we were looking into pattern results. We changed the pattern result length here in the sizes, the indices. So it's probably in that, I imagine. Possibly there. We are collapsing here and throwing this error here and collapse at. When we run out of pattern indices, picking a pattern, we either have a collapsed cell or we don't. So the remaining patterns, we get a random between 0 and the total cell weight, get the possible patterns, and then over those possible patterns we go P's. So either P's is initially empty or we go through all of these and we never end up picking one. So let us just check what's happening there. And put that there, show P's. Then we'll import debug.trace up here with pre-fixed qualified. And then we'll just see what happens, what gets built here. Okay. So we have one iteration, it picks up all 16. A few of those. Yes, we've collapsed a few. And then we hit can't find to collapse to. So that must mean that it's not going into our recursive go function. It must mean that inside go we are collapsing down to it. And we're not expecting to, I don't think. So if we get on the natural recursion, we'll stick a trace on there. Oops, I accidentally deleted something I didn't mean to. Boop, boop, boop. There it is. All right. Okay. Let's see what we get now. Yeah, there we are. So in a lot of cases, we're collapsing down, we're picking something. But for some reason, this cell is going down to our case where we're not expecting to. I don't know if that has... What could that have to do with our pattern indices here? Did we mess something up in that commit that... no, not this one. Pattern results. Maybe there's supposed to be more patterns that we initialize with. That might explain things. Oops. Dear. Maybe it's supposed to be keys -1. Get rid of that. We could check out that commit and see if it actually the test passes on it. That's my suspicion. What can I do? I can cherry pick here. How do I do that? I can't remember. Git. Think I can. What is it again? I just check out, of course. All right. Okay, that was working. Good. Master. Main. Master. Main. Hey, Storm Collective. How's it going? Welcome back. Okay, so that commit worked. This committed? The commit we just created is the one that broke that test for some reason? Gotta be, I guess. What did we do then? What's up, Swarm Collective? What have you been up to? What have you been working on? Getting ready for holidays, or what's going on in your world? Texture from list. Only really defined in this module. Does the spec use it? Maybe the test uses it. Test. Okay. We do. Okay. That is probably what it is then. Got some groceries for this week. Nice. Preparation for the feast. Yeah, right on. Same here. Although, I'm not in that country, so I don't celebrate it, but yeah, I work with a lot of people who do. A lot of good coworkers, a lot of friends, so nice. Okay, so texture from list is probably like I'm doing something stupid with. I did something wrong with, it looks like. So size, we give 3 here. 0, 1, 2, 3. Looks like this should be 4 for 1. This example. And then we want pictures. We want the pattern results of size 3. That's okay. So sub patterns will be like 3 by 3. So that'll be one pattern, and then it'll get the next pattern like this, so on and so forth. Slice those out, which is what I think we want for this test, and then. Yeah, it sure does. So we try to make sure that it wraps around once. Oh, it should get this column, and then the final column back to 0 again, or that last one in this row. And then it'll go to the next row, which will be one more down here. And it'll get like, that one will be the next pattern. And then this one. And then one more from that. And then, so that's 3 rows. I should get this one as well, wrapped around to the first row. And 3 of those. I think that's all it would do. So we'd get 9 patterns out of this. I think. But, well, we could debug that and actually see if that's true. I think we could print that out here without evaluating anything. We'll show that. It says the pattern result max index is 25. Quite a bit more than I was thinking. The pattern size here is 3. That's what we wanted. Pattern size of 3, yeah. Okay, and then Haskell Kitty just came back. Okay, let's see. So, pattern results. We didn't change that. We just changed the input texture. Maybe this should be, this is the off by 1 error here, maybe? They should all be offset. Ah. It's if you get a sheet of grid paper out and draw it, it works pretty well. So you say a 4x4 texture with 3x3 pattern results in 16. Right? I think that... Well, aside of... Assuming there's no duplicated patterns, yes. Because we also filter for those out. Filters those out, I believe, if I'm not mistaken. So yeah, if you had 4 columns here, 3 each, you get 1, 2, 3, 4 per row. 4x4 is 16, so yeah. Although now it's saying pattern results that we're actually getting quite a bit more than that. Should get like 25. No, 16. Okay, so that change actually did something. That's right. So you're right, 16, I think. We still can't find the pattern to collapse to, though. So maybe... What about the change? Either we're revealing a bug that was already there. We just couldn't find it, but we couldn't see it before because we didn't trigger it. Or something about the way we're constructing texture from lists is making it very unhappy. When we cut the patterns out from it. Okay, so the array is undefined if any index in the list is out of bounds. The 2010 report further specifies if any two associations in the list have the same index, the value at that index is undefined. However, in GHC's implementation, the value at such an index is the value part of the last association with that index in the list. Because the indices must be checked for these errors, array is strict in the bounds argument and in the indices of the association list, but non-strict in the values. Thus, recurrences such as the following are possible. Not every index within the bounds of the array need appear in the association list, but the values associated with indices that do not appear will be undefined. If in any dimension the lower bound is greater than the upper bound, the array is legal but empty. Indexing an empty array always gives an array bounds error. Bounds still yields the bounds with which it was constructed. Okay. Each of the 4x4 would be the start point. And duplicate patterns would make it 16 or less. Yeah. I think with the duplicate ones, we just increase the frequency count of how often that one appears, but we don't keep it in the set of patterns. So the frequency hints say like, okay, well, if I've seen this pattern 3 times in the input, then when I'm generating the output, I'll be more likely to choose that one. So it appeared more times in the input. Okay, so if my association list should have all of the indices that we want for this test case, I believe. How can we check this out? We could break this up a little bit here. That's all nice and Yankee Doodle, but let's comment that out. Put in a slightly different version where we let bind all of these things. And socks equals that. Current texture TA. Oh, we can't do point free anymore, so we gotta go X's here. What the hell is this? Ugh. Thanks, Windows. Right in the middle of my stream. You know, but speaking of that, I friggin' hate modern computers. I swear to God. They do so much crap while I don't want them to. Like, maybe you would like this. Maybe you want to be notified about this right now. And I'm like, no. No, I don't. Thank you very much for asking, though. Good Lord. Maybe you want to see an ad. I don't want to see an ad right now, Windows. I really don't. Linux is better at this, but it still kind of does it sometimes. It's probably the best out of all the major operating systems that people use these days. But back in my day, when I used to power on my Amiga, didn't do anything if it just sat there. Right? Totally, Swarm Collective. Okay, we'll debug.trace texture from list here. T soaks. Ooh. I don't have a show instance on the A's there. I think we can just add it. Data results, texture from list. Okay. So is this the association list we get? Just gonna pop it in a little buffer here. One, two, three, four. Okay, there we go. That. Boom. 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 And then the last one. Okay, that's the transformation we're getting when we go texture from list in the spec test there. Alright, so we see the ones, column of ones here matches up to this column of ones. Alright. We should have 0, 0, 1 here. And 0, 0, 1, 0. 0, 0, 1, 0 in the file column, 0, 0, 1, 0 in the other column. So that's, the values are good. The indices, we got 0, 0, 1, 0, 2, 0, 3, 0. 0, 1, 1, 1, 2, 1, 3, 1. 0, 2, 1, 2, 2, 2, 3, 2. 0, 3, 1, 3, 2, 3, 3, 3. Something, 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 something. Something is tweaking my brain here. I think, what am I thinking? I think I know why this is, I think maybe I know why this might be possibly, potentially breaking this test. These appear like the right values, but they're not at the right... Don't think they're the exact indices. Right, so 0, 1 should be 1, but 0, 1 is actually 0. And between the two patches, where the patch before we tested works, and then we change texture from list, we change these indices, and then it doesn't anymore. Could be the reason why. Okay. The reason why we were doing this change on the indices, though, was just because we were using texture from list in the visualizer to get the data out of the PNG in the correct, from the correct indices into our textures thing. I don't think that's working here for this test case where we're like manually constructing an input texture for the algorithm. There's like a difference there. Okay. So what do? Boom, boom. Let's get back to here. Get rid of all of that. I will kill this commit. We haven't pushed it. Yeah, I'll just revert it. Nine, 7, F4. Okay, what we actually need to do, what do we actually need to do to make this work? So this should be compiling again and working, and everything's fine now. There it is, okay. All right, let's look in app main. Okay, so we have texture from list here in our from surface function. This is where we're having issues. We run this. It's gonna like take a while to load. It's gonna like show up as blue with a couple of weird blue pixels here and there, or blocks, blobs in weird places unexpectedly. And my theory was that the reason why this is because in the PNG format, the indices in which we get those pixels are different from the indices that go into creating the texture, if that makes sense. They're coming in kind of rotated. So when we use list array in texture from list, that's the problem. Okay, but in the spec, when we're using the spec, we're giving the texture in this kind of list array order, and that seems to work just fine. Even though when we specify it that way, we're kind of assuming that the patterns we get are like this. The sub pattern we get should be, the first one should be that. Okay, let's attest that assumption, that that's true. Debug.trace, debug, fail. Trace in here. We know pattern result is not empty, so I'm just going to show the head of that. Pattern result patterns. Okay. Now we use list array on this chunky boy. Okay, copy and paste that again. Okay, so it should be 3 by 3. So it's 1, 2, 3. There, and this one like there. So this is the sub pattern that it's at the head of patterns list. Compare it to the spec. Should get 0, 0, 1. 0, 0 should be 0, but it's 1. Okay. And then 0, 1 should be 0. That's right. And 0, 2 should be 1, but that's 0. Like 0, 1, 0. Or no, we got a 0, 0, 1. Sideways. Yeah, it's like... Oh, there might be some deeper things going on there. Yeah, I think there's some not goodness in that. That's probably not right. Okay, how do we fix this then? Sheesh. Good gosh. Yeah, it's not the sub pattern I was expecting. So that's probably cause of what's going on here a little bit, maybe. Let's get rid of the debugger. There. Okay, let's go into wave function collapse. Okay. Our texture from list. Okay. This one is the no bueno one. Ish, I think. That one was pretty good. This cat. That's gonna break our test. That's fine. I'm gonna load this up. I'm gonna bring in an example from the spec. Although the parameters on it are wrong, actually. This should actually be 4, so maybe that's what's going weird with it. set -x type applications. All right, so at 0, 0, we get 1. Or we get 0, 0, 1, we get 0, and at 0, 2, we get 1, and at 0, 3, we get 0. That's the first column. Correct. Okay, then 1, 0, we get 1. 1, 1, we get 1. 2, we get 1. 1, 3, we get 1. That's the next column. That's correct. 2, 0, 0, 2, 1, 0, 2, 2 is 1. Okay, 2, 3 is 0, so on and so forth. Okay. Yeah, that looks right. And if fixing that breaks it, then our the way we're punching out our subpatterns is probably also based off of this list array function, I'd imagine. It's probably where we're going a little bit wonky. So extract pattern. Yeah, we're doing list array again here. There we go. All right, we don't want list array. We don't want to use that because it generates the index order for us in the wrong order. Ah, okay, no problem. Storm Collective. So when you use list array, bring in data.array. Okay. So we're gonna construct an array from like 0, 0 to 2, 2. That's gonna be the bounds. Yes, I believe that's the issue with it. All right, so 0, 0. 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8. All right, so you get the indices become 0, 0, and it increases in y. And then we go 1. So we're basically going column. Yeah. So the expectation, I think, when we were writing the code is that it was going the other way. And so we're rotating all of the things we're slicing out, rotating all the textures we're loading in, all that sort of stuff. So let us create a little helper function for that based off of what we have for texture from list. This is the key part, is creating the indices that we want. What does this look like? Blue. Right, we need the A's, we need the size. And then we get a list of tuples. word to word in A. What should we call foo? Rose? Don't want array quite like that. Want array.array with the rows. Rows of size. No, width. No texture elements. Did we break anything? Maybe. Okay, off by one. A couple of places. There. Okay, we didn't break anything. That's good. Let me, let's try running it again. Okay, we get slightly different output, but it's not quite right yet. It's different than what we had before. Stream. Okay, let's go back to the spec then. Let me pop that debugging back in again and see if we get the right subpattern that we were expecting as before. Qualify, trace. Let's debug. Let's go. Okay. Here it is. The head of pattern result, pattern result, patterns. Okay, let's check this one. All right, 1, 2, 3. Okay. 3. This is looking a little more promising off the hop. Comparing with our spec. Okay, we're expecting something that looks kind of like a sword. 111, 010, 100 though. Something fishy there. Yeah, it's not quite right. Pattern size is 3. The array bounds is 0, 0 to 2, 2. None of those indices go out of bounds there. Okay. Surprisingly, we didn't break anything, but that's not right. I mean, that test is not very conclusive. It just tests that it runs, and we get slightly different output. We probably could have more fine-grained ones for this code here. Okay, so patterns. This is where we cut the cookies out. Okay, this is where we're getting the source indices from our source texture. Here. So this equation for indices here is getting the indices in the source texture to extract into the subpattern that we're constructing. Okay, so when we go to extract the pattern, x initially, y should be in the first iteration, in the first pattern, should be 0, 0, which seems like it is, given that right here, right? But it's getting the value 1 instead. So texture elms is where we fold over the indices and we accumulate the elements from the source texture. So we index into the source texture at that index. And for some reason, our source texture at 0, 0 thinks the index is 1. Oh, the value there is 1 in that array. Okay. No, that's gonna be nice. It's a fill value. It's gonna be all the same. Anyway, yeah. Okay. So 0 texture from list. Oh, that's right. I forgot. Yeah, this parameter here is wrong. Okay, no, 0, 0 is still 1. And for this subpattern, yeah, so this should be getting the same value. Like the indices happens because of the subpattern we're looking at overlap with the source texture, so they should be the same. Whereas 1, 1 in the source texture would be index 0, 0 in the subpattern if we were to say selecting this one out. Okay, so yeah, 0, 0 should be 0, not that. All right. Let us create a test for this then. Let's use an example. The source texture. It should return the matching values for the subpattern indices. Hopefully that makes sense from an English speaking perspective and the spec perspective. Basically what we want is to have a texture using texture from list. Very similar to our guy down here. Okay, and then we can get the subpattern. Let me put this over here like this. Get the patterns from texture of size 3. All right. Then what we're saying is that the indices and values 0, 0, 1, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2, all those indices and all those values of the subpattern should overlap with the source textures things. So, we took let's say T is a list array, this guy. We took patterns from T of size 3. sorry, T is an array, not. Times T. Texture. Great. Okay. So if I get the head of that, pattern, result, patterns. Yeah, we take patterns of T prime, size 3. Okay, we get this pattern here. And if we look at T prime, 0, 0, 0, 1, 0, 2, 1, 1. So those indices should overlap, which means the association list of patterns anyways, the association list of the pattern should be a prefix of the association list of the texture. That's what I'm trying to express here. I'd have to use the function of that. Get pattern from P. Fine. Okay, get pattern from P, the assocs of that. Okay. Oh, wait. 0, 0 is 8. Four, 3, 2, 1, 0. Oh, sorry, that's the wrong assocs. Isn't it? P is a pattern. No. Seven, 6, 5, 4, 3, 2, 1, 0. 6, 8, 7, 3, 5, 4, 0, 2, 1. Where's it getting that data from? Ah, okay. Okay. Something funky going on there. It's getting the right indices, but I don't know where the heck it's getting those values from. That's weird. So anyways, the formula I want in this test should be that the association list of burst pattern. So we want the head of get patterns, or no, pattern result patterns from patterns texture 3. Okay. So this pattern should be this one here. And the indices of this particular pattern should coincide with the indices and the values in the source texture. Just by coincidence and virtue of being at the top left there. So 0, 0 in this sub pattern should also be the 0, 0 in the source texture, and they should be the same value. So what if we take that association list, or just the values, just the indices. Yeah, let's just get the indices of those, actually. Keys. Indexes. Okay, and then we get those, we basically fold over those, getting the values out from the source texture. And then get values, start the empty list over pat indexes. Get value. It's going to be the these and the current index. We'll have to get text, so that'll be T. He's an X, and then basically we accumulate onto these some value. That value is going to be texture array T. array.bang of x. And then tech values could be the same as the array.elements of path.getPattern. Let's focus in on that test. Fold L prime, we have to import that. Okay, and then what do we got? Okay. Cool. So we're not getting the expected values. All right, there's our test. So if we can make this test pass, I think hopefully we should be able to get the rest. Maybe, hopefully, we'll start falling in place. Okay. Yeah, I think that test is good because we're constructing the array indices explicitly pattern index, and we're folding over those and mixing entity exactly with that. Okay. Yeah. Okay. So, patterns. Oh, we're also assuming the head pattern, the first pattern here as well, so. This would not necessarily be true for other subpatterns. Right, so we extracted this one here. The subpattern's index 0, 0 should have value 1, but the source texture index is actually 1, 0. Value 1. So, yeah. Only works for the top left subpattern. 1, 0, 0. The source texture. Almost like I want a projection function from those indices to the source and then back again. That would be pretty neat. Okay, so let's go look at patterns. Ba-bow, ba-bow. So the initial x and y should be 0, 0, so that should be the head of our list here, P's. So we extract pattern at 0, 0, and that should be the one we're testing with a subpattern size of 3. So when we go to extract here, we go A should initially be 0, 0. And I guess according to our test, that's right. But then we expected 1 and got 0 instead. And I think that might be because we're constructing these indices in, again, not the row order here either. So we look at our rows function. This is good for cycling through arbitrary, like rows of size 3 of an arbitrary list. So if we wanted to break up this list from like, I don't know, 0 up to 100, say 20. Make it not too big. Three and 0 to 20. Zero, 1, 2, 3, 4, 8, 9, 10, 20. Okay. So the input list is the numbers 0 to 20, and then we generate the indices for the rows of length 3, starting at 0. Now, patterns. When we construct these indices, right, we go from 0 to 0 plus width. Width is size minus 1. So if that was 3, it would be from 0 to 2 inclusive. And 0 to 2 inclusive. We take the mod of the size so that they wrap around. So in this sequence, we would get A is fine. Let's say the size we said 3, and X is 0, 0. Y would be 0, 0 initially. And W is going to be size minus 1, which will be 2, 2. Oops, not 3. Okay. I'm missing a parenthesis. So then we get 0, 0, 0, 1, 0, 2, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. So we're increasing in Y here. Okay, and the list, the order on the list is dependent, important. So that's why our lists aren't matching. I think they have the right set of values, perhaps. So if we flip these around, would that make the test work? And it does. Okay, let's take the focus off that and see if the rest of our tests work now. Okay, not quite. Okay, we're getting a collapse 2 again. Maybe because we're using more list array type doohickeys when we're constructing things throughout the algorithm, perhaps? Or else are we using list array? Let's just get rid of that code there. Bam, gone. Make texture clockwise. The arbitrary instance, okay. Fill pattern, don't really worry about too much. Clockwise. That might be one. I don't ever use that. This use of all possibilities is creating... No, that should be fine. Grid might be it. That's a strong contender. And that one should be fine. And that one. That one. Okay, I'm gonna wager it's probably in grid. It's probably that. So we need to construct the array in that order as well. Because we go from a grid to an output texture. Repeat make cell. Well, we call make cell actually with a constant here, so we should. This is actually initializing the grid to the same cell values, which wouldn't make a difference. Or else we're using this array that I was like kind of sus about. Clockwise. What is clockwise used for again? Is it used at all? It is not. Get rid of it. think those single dimension is fine. Single dimensional arrays. And again, because repeats making constants, this will be filled in. Make cell. That's a one-dimensional array. Constant. That's just the arbitrary instance. Fill patterns. Probably don't actually use that. Okay, maybe not. Okay, let's see, what else? Oh, we do use it. Sorry. Well, back here again, where we started off at the beginning of the stream. Okay, so again, we're running out of pattern indices we couldn't find between possible patterns. Now, what have we changed? We've changed the way that textures are constructed so that their indices are in kind of like row order. And also the subpatterns, the way they're cut out, and the subpatterns are constructed. Patterns are now constructed in row order as well, which should match the source texture as we kind of like visualized and expected things to go. It could be that we're getting to contradiction state, perhaps, with the inputs here. Let's try the spec here. Actually, this is 4. The input texture is 3. Let's try a slightly different seed. Like maybe we just couldn't get one. Just got unlucky, but maybe not. Okay, let's double check this again. There we go, 1, 2, 3, 1, 2, 3, 2, 3, boom, okay. Oh, let's see, 0, 0. Maybe we didn't quite get it right. That's why things are breaking. So 0, 0 should be 0, but it's 1. looks like this is actually rotated to the right. We still have an index problem. Subpatterns. How did... I'd expect our test to be able to catch that, actually. How's runway catching that? Did I mess something up here? Bar? No. Okay. Change that back to hundreds. It wasn't the seed. Let's get the head pattern there. And this new test we just added. Subpattern indices. We get the head pattern results there as well. From the same texture. Right, same arguments. We're basically saying that if you take all the pattern indices from that pattern and you go get those values out of the source texture at each of those indices, then it should be the same as the elements of get pattern. Except list order matters. And that might be why that... Well, the test passes, so it could just happen to be... That array elements could just happen to be passing the values in the same order that we get them, we fold them here when we get the pattern indices out. But array indices and the array elements, I would expect those to return things in the same order, like the list with the same order as well. I think it's ascending in the keys. In index order. And indexes in ascending order. So that's why that would work. That's why that would work, and it still doesn't explain why we're getting a rotated one here, though, actually. Zero, 0, 1. Let's see. Go at. Focus in here. I want to see it. We do get 0, 0, 1. 0, 1, 0, and 0, 2. 0, 0. And so this test is saying that the texture T that we construct from texture from list also has a value 1 at 0, 0. Yeah. I have a sneaking suspicion it's my use of rows here. Because this gets all rows starting from 0, cycling around to the row length. But when we're extracting and constructing a sub pattern, no, that's right. Size is the sub pattern size, and we do want 0 to that size in the sub pattern array. No, that's fine. Yeah, let me. I'm gonna trace and want to show the texture. Yeah, so the textures array, the value at 0, 0 should be 0. But in the subpattern, the value at 0, 0 should also be 0. It's 1. Oh, this is weird. Okay. Let's show the pattern indexes that I was trying to use here. So that should be 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2. So when we get to get value, 0, 0 should be going 0, 0 into texture array, and 0, 0 the texture array is 0. Am I about to learn something mysterious about the internals of arrays in Haskell? so it doesn't say anything about the order dependence of the tuples in here of i's. Okay, so the array is undefined if any index in the list is out of bounds. I don't think any of the indices are out of bounds here. If any two associations in the list have the same index, I don't think that's happening. Value at the index is undefined. Because the indices must be checked for these errors or strict. Not every index within the bounds of the array needs to appear in the association list. Okay, but they do. If in any dimension the lower bound is greater than the upper bound, then the array is legal but empty. Indexing an empty array always gives an array bounds error. Nope. That's not the issue. Should literally be getting this. And yet it's still saying it's passing. Why? Ooh, Hmm. The order dependency between tech values and array elements.get patterns. They might just happen to coincide for the values, given the way that they're constructed. But it might not be right what we're like actually expecting. That we're folding over pattern indices and pattern array indices, which is, they should be the same order. And it's the array bang into X in the index here that's like getting me. Like, if it gets to 0, 0, I haven't done the find yet. Let me bring that back. Let's go to the test. Bring this in. Okay. These are all effing wrong. I go to tech. Sure. Okay, we get this array here. And if I add the module data.array, and then we go get texture tech, bang at 0, 0. What do we get? We get 0, as you would expect. And yet, the first element we get is 1 in tech values. Because, if we look at pattern indices, what? The first element should be 0, 0. So if we cons that on the front of these, it's going to be in reverse order. Yeah. Oh, swarm collective. The X and Y values of like the array index ones? Yeah, I think you would need some probably some kind of dependent typing to be able to do that. I was thinking about that a while ago, that like there's quite a few index things that could be caught, but yeah, you'd have to know. The type checker wouldn't be able to check things that, like if you're giving, you're using the index operator into an array, it doesn't know until runtime what the values actually are. that you're giving, but if it was dependently typed, it could know and know that that was an out-of-bound access. That would be pretty cool. I think similarly it might work for the coordinate, the individual components as well. Okay, so go back to patterns, over here. Mod size. What is it? What's the pattern here? We're off by... We just shift what we got. Like, rotate this a little bit so that this element comes first. And then we get 0, 0. They would all line up to what we expected. I feel like it is something in indices here. Why do I feel like that? It's the pattern. The texture. What is the power pattern indices? So 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2. And if we are consing them on in, as we do tech values, the fold L, then 0, 0 is going to be the first element. And then on the head of that list, we're going to put 1, 0, 1, 1. All right. So we're reversing it here. What if that wasn't the right thing? What if we just do it like this? These... Something done like that. I mean, I think that's the same thing, but... And it is. I need like a helper function. That's like, I think I do need, I think that helper function would be the translation from the source index space into the subpatterns index space and back again. And if I can reverse it back again, then we can, yeah, fold over these. Oh boy. Okay, well this stream's getting a little bit long and I gotta run. So unfortunately this is gonna remain broken for a bit. A bit longer. Until we get that all sorted out. Super duper, right? Okay, stage those. Work in progress. Get sub-pattern extraction right. We actually ended up using the modified detector from this, didn't we? There we go. That reverted that. We use rows now. Yeah. There. And here. Can we squish this all down? Does that make sense? Yeah, I'm just going to push them up the way it is. Forget it. It's all good. Okay. Thanks for hanging out and, you know, chilling with me. Hope you have been having a good time. And if you're not, that you will be soon. All the code for this project is up here on GitHub. I'm Agent Ultra on Twitch as well as on GitHub and other places. So if you want to check that out, go ahead. That's where you can follow along and mess with it. See if you can't, if you can read my code. Have an excellent, excellent, excellent feast, Swarm Collective. I hope it's amazing. If you want to follow along on the social media, the only one I really have, I guess, other than like YouTube and Twitch here and stuff, is on the Fediverse, on Mastodon. My profile here on the types.pl server. I'm Agent Ultra there as well. Has links to my website, agentultra.com, and my YouTube where I back up all my VODs and various other things. And if you follow me along on the Fediverse here on Mastodon, then I tend to post about the stream when I'm going on, things like that, things that I'm working on. I post polls, all kinds of stuff, as well as just fun little weird posts and such. Go to the link above me, of course, to declarative.tv. There's a cool little website, lists a bunch of other people who are streaming in various other programming languages in the kind of declarative style and declarative family, which Haskell is kind of loosely related to. And check that out there. There's a link to a Discord server. And if you go to the Discord server, there's a channel for this stream where you can, if you're watching this on YouTube because you're in a different time zone, you can chat about the projects or what you're working on and stuff. I hang out on that server quite a bit. And yeah, so thanks for watching again. I hope all your monads are free and all your types check. And we will catch you next week. I usually do these streams every Tuesday at about 10 after 8 in the Eastern time zone. But of course, you can subscribe here on Twitch. You can subscribe and follow on YouTube, set up your notifications and all that stuff, and then you'll get notified of that. So take care. Bye for now.